Welcome back to another Explainer. Today, we're literally diving into, a totally fascinating yet completely hidden vulnerability right at the foundation of our modern world. I'm talking about the construction materials sector. Normally when we think of this industry, we think of massive quarries, heavy machinery, big trucks. But their absolute biggest financial and operational vulnerability, it's actually not the rock. It's not the supply chain, and it's not even the fuel. It's something else entirely. A glaring weakness most people just completely walk right past. So picture the heavy building blocks of our cities. Cement, aggregates, glass, plastics, bricks, the whole shebang. When you visualize these materials, you're probably picturing incredibly dry, solid, dusty objects, right? Well, challenge yourself for a second. What could possibly be the single most critical vulnerability to producing these bone-dry materials? What hidden cost could literally bring a massive, multi-million-dollar cement operation to a screeching halt? Okay, let's ground this in the official data. We're looking at the SASB standard for construction materials, which is backed by the IFRS Foundation. Now keep in mind, this isn't some niche environmental advocacy brochure. This is a rigorous, hard-hitting accounting standard that global investors use to spot serious, material financial risks to a company's cash flow. And when these financial heavyweights look at construction materials, they flag one specific issue with massive importance. And that brings us to the big reveal. The massive hidden ingredient is water. Crazy, right? It totally shatters this perception we have that heavy industry is just about dry, dusty rock. The reality on the ground is that turning raw minerals into anything usable requires vast, continuous rivers of liquid. We're talking cooling machinery, washing aggregates, suppressing dust, complex chemical processing. Without massive amounts of water flowing in, the rock literally stays in the ground and the kilns shut down completely. The SASB framework, they do not mince words about this. The standard states point-blank, construction materials production requires substantial volumes of water. That really highlights the sheer, undeniable scale we're dealing with here. Water isn't just some minor side input, it is a fundamental operational necessity. And look, when a business needs substantial volumes of a resource that is becoming, let's face it, increasingly unpredictable to source, well, that creates a huge red flag for investors. Now, what's genuinely fascinating is how the standard actually breaks this dependency down. They categorize it into three distinct risks for these companies. It's not just a single point of failure. First up, you have operational risk. This is the obvious one, literally just not having enough water to physically run the plant. Then you've got regulatory risk. Think sudden government caps on how much water you can pump, or really strict new rules on wastewater. And finally, reputational risk. How does the local public view the company's water usage? Let's follow the money here and look at the two major financial outcomes of getting water management wrong. It really comes down to a sudden shock versus a slow bleed. On one hand, an inability to secure a stable supply leads straight to production disruptions. Boom, operational halt. On the other hand, you have rising water prices leading to increased production costs. So depending on where they are, a company might face a sudden shutdown from a flash drought, or they might just watch their profit margins slowly bleed out as they pay huge premiums just to keep the water flowing. And hey, the pressure isn't just coming from a changing climate. These plants are facing fierce, intense competition for incredibly limited resources. A giant cement plant doesn't exist in a vacuum, right? They're competing head-to-head with local communities, local farmers, and other industries for the exact same local water supply. If a nearby town is suddenly facing a drinking water shortage, well, a plant consuming thousands of cubic meters of water a day is going to face intense public scrutiny, probably regulatory shutdowns, and massive reputational damage. This brings us to a concept we can call the scarcity multiplier. All of those financial and operational risks we just talked about, they scale up exponentially in regions that are already facing water scarcity. If you're operating in a water-abundant region, fine, maybe you just pay your utility bill and move on. But in a scarce region, suddenly potential water constraints and price volatility aren't just an annoyance. They become a daily existential threat to the entire business model. So how do investors actually measure this vulnerability? Because as the old saying goes, you can't manage what you don't measure. In sustainability accounting, it all starts with one absolutely vital distinction: water withdrawn versus water consumed. And trust me, these are very different things. Withdrawn is just the total amount of water you take into the facility, from a river, groundwater, a municipality, whatever. But consumed, well, that is a much more specific and honestly way more critical metric. The standards definition brilliantly illustrates what consumed actually means when we're doing rigorous accounting. Water is considered consumed if it evaporates, if it gets directly incorporated into the product, like the actual water chemically bound inside ready-mix concrete, or if it's discharged into a completely different catchment area. Essentially, consumed water is water that never, ever returns to its original local source. It is permanently removed from that specific local ecosystem. Actually, here is a really cool, quick detail from the technical protocols, just to make you feel like a total industry insider. When companies report on their fresh water usage, how do they actually define what fresh means? Well, if local laws don't specifically say, the SASB standard steps in and defines freshwater as having less than 1,000 parts per million of dissolved solids. It's this highly precise metric designed to ensure that every company all over the globe is speaking the exact same accounting language.
All right, let's look at how all this builds into the ultimate risk metric. Knowing your total water withdrawal is a great start, for sure. But knowing exactly where that water is being drawn from, that is everything. Companies are actually required to map their operations to see exactly what slice of their water footprint sits directly in danger zones. Because think about it. A company drawing 1 million cubic meters of water in a rainy, low-stress valley has a vastly different risk profile than a company drawing that exact same amount in the middle of a desert.
To keep this mapping totally standardized, the framework points everybody to one specific tool, the World Resources Institute's Aqueduct tool, specifically their Water Risk Atlas. Companies have to use this to identify any operations located in areas with high baseline water stress, which means 40 to 80% stressed, or extremely high baseline water stress, which is anything over 80%. This takes all the guesswork out of assessing geographic risk. The data is just right there. And it all comes together right here in the official SASB accounting metric, EMCM 140A.1. This brilliant little code takes all our definitions and puts them into a standardized, reportable format. Companies must disclose total water withdrawn, total water consumed, and, here is the kicker, the exact percentage of those totals occurring in those high or extremely high stress regions. This is exactly the dashboard an investor uses to instantly gauge a company's real exposure to water supply shocks. So you're probably wondering, how do these companies actually defend against all this? Well, to wrap up our core analysis, let's look at a massive silver lining. Adopting water-reducing technologies isn't just some nice-to-have PR win for the environment. According to the standard, it directly lowers operating costs and heavily shields the company's cash flows. By minimizing how much water they actually need, these entities essentially bulletproof themselves against sudden shortages, community backlash, and strict new regulations. In this industry, efficiency literally equals financial resilience. I want to leave you with a final, slightly provocative thought to chew on. If water prices suddenly double tomorrow in key industrial regions around the world, which building materials companies do you think would actually survive? The ones treating water like an endless, cheap utility? Or the ones who've rigorously mapped out metric EM CM 148.1 and engineered their water dependency down to be absolute bare minimum? The hidden liquid cost of heavy industry is very real, it is highly measurable, and it's the ultimate dividing line between resilient businesses and incredibly vulnerable ones. Thanks so much for joining me for this explainer, and I'll catch you in the next one.